I'm Dave Kassler, amateur radio call sign KE0OG, here today with Ask Dave episode 105. Today we'll explore the wild, wonderful, and woolly world of QRP. QRP is one of the dozens of Q signals that hams have used for years to communicate with each other quickly. And QRP means, please reduce your power. In actual ham use, it means low-powered transmitters, usually not exceeding 5 watts. Deliberately operating with low power, only 5 watts when 1500 PEP watts are allowed, may seem kind of dumb. And there are many hams who say, life is too short for QRP. But on HF, small, low-powered CW Morse code transceivers can do remarkably well. In terms of getting through, using CW at 5 watts is about equivalent to 100 watts on single sideband, so you still get lots of QSOs. There are other attractions to QRP radios. Most of these are offered as kits, so here's an opportunity to literally build your own radio. Also, the cost of a good QRP single-band radio can be quite low compared to commercial gear. Now, I do note in passing that there are some very expensive QRP radios out there, if that's your cup of tea. For many years, I have recommended that new hams not try QRP as their first HF radio. I continue to make this recommendation for 2 reasons. First, almost all successful QRP is on CW, so you'll need to learn Morse. It's not hard in the sense that Einstein's equations of relativity and gravity are hard, but rather it's hard in the sense that you need to keep at it for several weeks or months, including getting lots of on-the-air activity. Second, low power is, after all, low power. To have a better chance of success at QRP, it helps to have some previous HF experience with a full 100 watts. That said, I'd like to point out that all hams, including technicians, have CW privileges on 80, 40, 15, and 10 meters. So if you're game, you can certainly give it a try. Remember, technicians have these privileges. Back when I was first a novice ham, like all other hams at the time, my only allowed mode was CW. In fact, my first QRP radio was a Heathkit HW7, which I had in college at BYU in the mid-1970s. With that radio, from a mountaintop in California, I had a QSO with a ham in New Jersey using 3 watts on CW. 3 watts is less power than a good flashlight, and the energy from my transmitter made it clear across the continent. I still think ham radio is magic. Heathkit's follow-on radio was the HW8, still a much sought-after radio for QRP equipment collectors. QRP has always been there as a sub-hobby of ham radio, but there have been surges of interest here and there. The 1980s and 90s saw lots of interest. QRP-only clubs formed. The ARRL has a QRP station class in the field day rules. And the ARRL still publishes several books on QRP. And all sorts of equipment has appeared over the years. And nowadays, the prepper movement has become very interested in small transceivers that will work well in the field. I have here on display 6 radios from different eras. 4 of these are CW only, 1 is PSK31 type digital modes only, and 1 is single sideband only. A couple of these radios stretch back more than 25 years, and 1 just came out this year. First is the MFJ 9040 single band 5 watt or so QRP transceiver. I remember when these first came out about 1992. Everybody wanted one. They were actually sort of expensive. I think it was around $200 or so. Looking inside, we note some common conventions from the era. The tuning control is a variable capacitor, which was standard practice in radio for many decades. We see no tubes, of course. It's all transistors and ICs. This radio used a popular oscillator mixer IC in several different roles. Note these square cans. These are holdovers from back in the 1930s when IF transformers used tunable coils in square aluminum cans. Note that there are a few of the new breed of inductors in the form of toroids. The RF output was an SO239 connector for mating directly with a PL259 coax connector. Also, and I ran into this yesterday when I did an alignment of this 25-year-old radio, is that the key, speaker, and earphone jacks are all mono. You can't even get mono cables anymore. When I plug in my good headset, I hear only in one ear. Clearly, I need to upgrade this unit with stereo connectors. Also note that this rig comes with a built-in speaker. The magnet on the speaker is strong enough to actually detune everything when the cabinet is closed up. For the last several years, most QRP radios come without speakers. You can use headphones or powered computer speakers. Some are strong enough to drive speakers directly. I had many great QSOs with this rig and plan to have many more. Yesterday, I hooked up the rig to my signal generator and oscilloscope and went through what MFJ calls a field alignment. Some of the old trimmer resistors and trimmer capacitors hadn't been moved in 25 years and were a bit reluctant to wake up and get back to work. Fortunately, I had the right non-metallic tools for adjusting the cans, and I think the rig's in pretty good shape. It puts out about 4¼ watts on my 12-volt battery here. I look forward to putting it back on the air. This next one is a kit that was available from Dan's Small Parts, an outfit very much into QRP at the time. I am fond of this kit because my daughter and I assembled it together when she was in middle school. I could build it for any band between 80 and 20 meters and chose 30 meters, which was just newly seeing activity then. Now, on this kit, I had to supply my own case. I put the volume, RIT, and tuning controls too close together. I chose to use an SO239 connector for RF. Note this also had a variable capacitor for tuning. Everyone likes these, but they were getting expensive, and nowadays it's exceedingly rare to see these variable capacitors in newer rigs. One thing I appreciated about the instructions for this kit is that it would have you build a small subsection and then test it. That way, when the whole thing came together, there was a much higher probability it would work, which it did. Note that the resistors and even a toroid lay flat on the board. Interestingly, when doing final testing with components all over everywhere on my desk, I heard a CQ. I quickly found my key, connected it with clip leads, I think, and replied. The ham on the other end was in Seattle, and I was at the time near Boulder. So it was great fun to do the final testing with the real QSO. This rig continued to be a great performer and the means for many successful CW QSOs. This radio is the next to get the alignment treatment. Now, here's a unique one. This is a small QRP rig, about 2 watts, called the PSK-80 Warbler, after the sound that a PSK-31 signal creates on the air. This kit was created by the New Jersey QRP Club. It's designed around PSK-31, meaning it's technically a highly specialized single sideband transceiver. The idea back then was that by using NVIS techniques on 80 meters, something easy to do, All the gang could have their warblers connected to their computers using Digipan all the time, and this would serve as a sort of intercom. Anyone could type while everyone else listened. And given its 2 kilohertz bandwidth, multiple signals could be going at the same time. Now, this old kit has audio in, audio out, and RS-232. So it plugged into your computer's regular sound card, and back then, some computers still had RS-232 connections. Not anymore. Well, that's not how we do sound cards today, so this kit is relegated to memory. I had one QSO with it. Steve Schroeder, KI0KY, lives across the valley about 40 miles away, and we had one QSO so I could check it out. It worked. Barely. It was interesting to build, particularly because it has 2 surface mount components that the kit builder had to attach himself. I spent a lot of time on those. Note that the output is a BNC jack. That is really common these days for QRP rigs. The next kit is actually a fairly old kit, but it's still being sold, and it has been on the market for a very long time. This is the Oak Hills Research 100A. I got it as a Christmas present a couple years ago. It's 20-meter single-band CW. The components are spaced out nicely, and most of the resistors lay flat. Further, all external connections, except for power out, have little connectors on the board, which makes for easy final assembly. There are no cans, but lots of toroids. Some of the toroids have multiple windings. Also, I point out that the traditional tuning capacitor is missing, replaced by a variable resistor running a voltage-controlled oscillator. Note the extra holes that are there for in case you buy a couple expansion kits, such as an electronic keyer made just for this. Also note the SO239. At first, I was quite delighted with it and even wrote a nice review on my website. But then problems surfaced. Unbeknownst to me, I had mixed up a couple diodes, and a small diode was where there should be a big diode. Continued use was messing up the small diode, and within a couple weeks, it wasn't working well at all. Marshall M., N1FN, who runs Oak Hills Research and several associated companies, was extremely helpful, and we exchanged many emails. But I finally had to send it back to him with a request to make it work right. By the time I paid for the shipping and his repair and alignment labor, I about doubled the price of the rig. That's too bad, and it boiled down to one skill I just don't have, and that's desoldering, removing components and leaving the circuit board hole clean of solder so another component can be substituted. It just seems beyond me. I watch videos on YouTube about desoldering that look so easy, but I can't manage it. Anyway, this rig puts out about 4 watts on 20 meters, and I've had many great QSOs with this rig. Now, here's a fun one. This is actually a single sideband QRP rig for 40 meters. It's the brainchild of Ashar Farhan, VU2 ESE of India. The problem he's trying to solve is the scarcity of affordable ham equipment in India. So he had the idea of creating a kit in which the board is complete, but the peripherals had to be mounted in a cabinet of some sort. Word got out to the USA, and Farhan started shipping the rig to hams all over the world for the stunning low price of $59 US post-paid worldwide. He was running behind on orders for a while, but after a wait of a few weeks, mine showed up. I made several videos about this radio, which caught the QRP world by storm. The user group has suggested many modifications. Mine is close to stock except for a modification in the tuning system. The radio is completely analog using a technology Farhan created called bidirectional amplifiers. The single board radio uses lots and lots of surface mount components, but fortunately, the board comes completely built. Now, this part over here is different. The built-in VFO has always been rather drifty, so Farhand combined an Arduino with a new chip that has taken ham radio designers by storm, the SI5351, which is 3 separate programmable oscillators all in one tiny surface mount chip. He calls the combination of the Arduino and the RF oscillator the Raduino board. Now, given that the Arduino is a small computer, he added a little screen, 2 lines, to show what frequency is being used. The only connection between this little Raduino and the single board transceiver is this one 2-wire cable, which injects the RF output of the Raduino into the VFO output on the board. There's a big and very active user community behind this radio. Many people have taken advantage of the Raduino and have written modified code to make the radio jump cartwheels. Subscriber Michael Struzik, AB1YK, made this nifty case for me. The hole for the display board was previously cut, and I added several holes for the knobs, buttons, and whatnot. I didn't use the supplied BNC jack, but rather substituted an SO239. The rig does work, by the way. The kit provided a small microphone element, which I mounted on a pen for convenience. It's hard to get attention in the 40-meter single sideband band, dominated by 100 or more watt radios. I think most people who have this radio are having fun with various modifications. Lastly, I'd like to show you a radio that is, shall we say, state-of-the-art for inexpensive QRP rigs. This is the QRP Labs QCX CW transceiver. Again, single band for a band you specify when you order. There are 2 surface mount chips, including that remarkable SI5351 chip that seems to be coming around much more frequently these days. What's remarkable about this kit is its price, $49 US, which includes postage. The guy who developed it, Hans Summers, G0UPL, is from the UK. The kit itself ships from Japan. They're running behind on orders right now, but that's being overcome. Mine took 7 days from the time they told me it shipped until it arrived here in Ridgeway. That's not bad. To keep the costs down, the circuit board is small and it can be a challenge getting all those parts in the tiny holes. I completed the kit last Sunday and it's in the troubleshooting stage right now. At least the digital part works. The kit has several toroids wound at what seemed to me to be at subatomic levels, and I don't have it all working yet. One cool thing about the rig is the built-in test equipment, a concept that showed up in the military many decades ago, but hasn't become common in ham radio until this kit. You can actually align it just with what's already built in. It even has a built-in microswitch that can be used as a Morse code key. My QCX is built for 40 meters, which I think is the most practical CW QRP band. It can have 2 independent VFOs or a RIT, that's receiver incremental tuning, which means you can tune the receiver a little off from the transmitter to kind of follow a station that's drifting. It has a built-in keyer with memories, and yes, it has stereo jacks for the earphones and key. Tuning is all digital, and there are frequency memories. You can also use this in beacon mode, either CW or WSPR whisper. It is a totally cool radio, and they are going out the doors so fast they are only now beginning to catch up. I very much look forward to using mine once I figure out the mistake I made. Note, I have once again come up against the bugaboo of my inability to desolder a circuit board hole. I think I'm going to need some private lessons. Once I get the radio working, I'll do a review. Now, my biggest QRP rig is my Yaesu FTDX 3000. Yep, it's normally a 100-watt rig, but it can be turned down to 5 watts. In fact, for FT8, I turn it down to about 20 watts, and when feeding my 100-watt amp, I turn it down to 62 watts so as not to overdrive the amp. Almost all, quote, normal radios can be turned down to 5 watts or less. One of the problems I've run into using a 100-watt radio turned down to 5, if the person on the other end is having trouble picking up all of my conversation, it's very easy to just reach over and turn that power knob up all the way to 100, which I've done more than once. So that's a short overview of my experience with QRP. I also have a whisper beacon from QRP Labs, which puts out about a 1/4 watt on 20 meters to the Chameleon P-loop antenna here in the shack. I get reception reports from all over the United States and Canada, and occasionally further afield. Remember, technician class licensees can use these simple CW-only transceivers on large portions of the 80 meter, 40 meter, 15 meter, and 10 meter CW bands. I recommend not 15 or 10 these days because the sunspots are pretty bad. Here's a great excuse to get on the air with someone you know and learn Morse code together. Find a buddy and give it a go. Join an organization such as the Straight Key Century Club at skccgroup.org. It will help you learn Morse code. Find a club that specializes in QRP. There are several out there at the national and local level. QRP is popular around the world. And then take it out in the field. Create a 40-meter dipole you can string between trees and put everything in a backpack. In fact, I'd recommend that your first QRP radio be 40 meters. By the way, if you have some fail-safe ideas about desoldering or have some favorite videos on the subject, do let me know in the comments. If I get the hang of it, I'll do a video on it. Thanks so much for your support. Stay tuned for info about next Wednesday's video. Until we next meet, 73. Next Wednesday, we'll look at what antenna modeling software says about verticals versus horizontal dipoles. You can click to watch last week's video or next week's video. Subscribe, like, click on the support logo to go to my support page.